Good afternoon, everyone. Today, inshallah, we will continue our session with the part of implicit functions theory. I need you to review most of the slides, all the slides. This is going to be the last lecture that's involved in our exam. I will do it today and tomorrow. Now we will go through two main topics which are really very important. The first of them is the implicit function theory. It's really very simple. The implicit function theory. Then we will go through how to identify a point of maximum or minimum or investigating a function for extremum in case of dealing with functions in several variables. And also I will go through some problems, hopefully today and tomorrow, from list number 7 or from sheet number 7. It's really very important to follow up and to have an idea, a very good idea, because of your exam on next Wednesday. It's going to be 9 a.m. in the morning till 11 or till 10:30. So please try to be on time, because after the exam you may have a field trip or something, not really sure, so please try to be on time. So study well, try to be on time, and remember this part, or the second part, that is this part that's going to be covered in the next midterm or in the coming midterm on Wednesday. It will contain a lot of stuff, starting from the functions in 3 dimensions. Remember the spherical and the polar coordinates, into the limits, into the definition of a function, into the differentiability, the continuity, and these parts also. Okay, let's start simply by the implicit function theory. The abbreviation for this function, are you with me, Ibrahim, is IFT, which is the implicit function theory. It is a powerful tool result in multivariable calculus that tells us when an equation involving multiple variables can be solved for one of them in terms of the others, even if we can't solve it explicitly. يعني ايه paragraph؟ يعني أنا ممكن يبقى عندي function فيها y و x, like for example y squared plus x squared equal 12. أنا الإيكويشن اللي أنا بتكلم عليها دي أقدر to solve it as y a function in x. يعني عايز اجيب متغير بدلاله الريست اوف فاريبلز، ده اللي بقصد بيه بالامبليسيت فانكشن. احيانا بقدر اعمل ده، احيانا ما بقدرش. يعني مثلا بص افتكر، لو انا عندي اكس سكوير ده واي سكوير ايكوال 16 فور اكزامبل، اقدر اموف الاكس تو ذا اذر سايد ويبقى واي سكوير بيساوي 16 minus x squared. Now I succeeded in making the function a function in one variable, getting y as a function in x, okay? But لو أنا عندي x square plus xy plus y square plus 12 equal to 0 مش هيبقى سهل عليا إنه to take or to make y function in the other variables. The implicit function will help you out even to find the partial derivative of y with respect to x, and it's really very simple. معايا يا أحمد؟ ما تسرحش. Okay. The conditions for solving the function. Number 1, you will have to have your function equal to 0. So if you have a function in multiple variables, the first step is to force this function to come to a 0 level. So bring all the variables and everything in one side. This is step 1. Okay, check at x naught y naught, the point that you need to find the partial derivative at this point. Check that f of x and y not equal to 0. This is must be checked. The second condition, I have to be sure that partial y, partial f, partial y at this point doesn't equal to 0. And you will know why. In order to get an implicit function derivative, partial derivative or derivative, you will have to check how many points, guys? 2 points. First of all, the function is equal to 0. Second part, that the derivative with respect to y is not equal to 0. Now, I can form f as x and y, which is going to be a function of x. I can form this guy. And also, simply, I can get d by dx. The definition is given and I sent you these slides. It's very important to go through them. It means we can locally solve for y as a function of x, even if the equation is complicated and we don't have a net formula for y. Yani even if I couldn't separate the equation and getting one on one side and all the rest of variables on the other side, I still can do it. Okay? The law is really very simple. Ahmad, the law is very simple. The law states that dy by dx, the derivative for y with respect to x, is going to be simply minus f of x divided by f of y. Remember that I put a condition that fy shouldn't equal to what? To 0, because you will divide omit down the road. Okay, guys? Okay. So that's the condition. Of course, f sub x is the partial derivative of f with respect to f of y, with respect to x, f sub y stand for the partial derivative of f with respect to y. Let's test this information on this example. It's an f of x or y equal y squared minus x to the power of 4 at 0, as you can see. Okay? Just checking on the of this camera. At the point negative 1, 1. Okay, the first thing I need to have the derivative of this function at that point. All I have to do, it's really very simple. All I have to do, just to check that the value of this function is equal to 0. So for f function at negative 1 and 1, once you start substituting, which is y squared minus x to the power of 4. Let's start substituting. So it's a negative 1 to the power of 2 minus, positive 1 to the power of 2 minus negative 1 to the power of 4. So it's going to be 1 minus 1, so the result is 0. So the first point is okay. The second check. I will get the derivative of this function with respect to y. Let's do it. Partial f partial of y at the point negative 1 and 1. Let's do it. Differentiate this function with respect to y. Once you differentiate with respect to y, you will find that this function equal to 2 over y. Now I will start substituting at this specific point where the y value equal to positive 1. So the result will be equal to 2, which is not equal to 0. So this is the second check. So the first check is okay, the second check is okay. Now I can find also partial f, partial x, which is simply gonna be, differentiate this guy, it's gonna be a negative of 4, a negative over 4 times x cubed. So once you start substituting at this point, you will have a negative 4 times negative 1, which is going to come up to positive 4. Now, I can get the derivative of y with respect to x according to the implicit function theorem, according to this implicit function theorem, which states dy by dx will equal to the negative of partial f partial x divided by partial f partial y, which is going to be partial f partial x is going to be a 4. That's the negative sign. Partial f partial y, it's going to be simply 2. So I can get the value of this derivative directly, even though I don't have this function. معايا يا شباب؟ طبعا انا بعمل substitution اهو، يعني ممكن لو انا حبيت اعمل substitution بتاعي it's very simple. Partial f partial x, which is going to be a negative over 4x cubed, and it is divided by partial f partial y, which is going to be a 2 over y, of course with negative sign, so it's going to come up to a positive value, and it's going to be 2 times x cubed over y, and so on. I can substitute and get this value. So it's really very simple. Now, once more, here is the value of f sub y, which is going to be 2y, replacing y by positive 1. I need you to wake up when you are making substitutions. Look for the x, look for the y. Usually these algebraic substitutions may you may have problems with it or make a mistake and get a mistake, so please be careful. So if y is equal to 2, which is not equal to 0, then the theorem says we can solve for y as a function of x. It's very, very simple. At x equal to 1, compare dy by dx minus f of x, direct substitutions. All I have to do is to differentiate with respect to x, negative 4x cubed over 2y. Negative times negative is going to be positive. 4 over 2, it's going to be 2. So it's going to come up to 2x cubed over y. Just to make the substitution. Replacing x by negative 1, y by 1. So you will get the value of this derivative, which is negative 2. By the idea, but I'm not going to use this law, but it is exactly, if you remember, in the olden times, just I'm checking that this part is within our camera. Yeah, I believe so. Okay. Look for this solution. If I have y squared minus a 4 x to the power 4 and is equal to 0. By the idea, I can use the method of implicit derivative, but we're not going to do it. But I want to show it to you, it's exactly the same. Okay? Let's differentiate with respect to x. Ibrahim, if I want to differentiate y squared with respect to x, what's going to be the result? It's going to be 2y times y dash, or dy by dx, minus a 4 of x cubed, which is equal to 0. Try to get y dash, which is dy by dx in one side. Now I'm succeeding in separating y dash. Possibly in some equations I could do it. In others I'm not going to be able to do this. Okay, y dash is going to equal to a 4 of x cubed divided by 2y. Remark, I've reached the same result at the implicit function theory. Okay, which means that the value of dy by dx is simply gonna be, just a second, it's gonna be 2 of an x cubed over y. So simply, if you're also substituting a negative 1 and 1, it's gonna lead to negative 2, exactly the same answer as we did. Okay, so that's a quick check for you for this function. In higher dimensions, if we are talking about higher dimensions, multivariable functions, we probably will have a function in several variables other than the two functions that we saw. So in this case, if f maps or make a transformation from Rm into Rm, yani mapping the stuff from the Rm plus m into Rm, this is why linear algebra is important. Okay? So the function is f of xy equal to 0. All I have to do is to check x belongs to Rm, y belongs to Rm. That's the function which must be continuous differentiability. And the continuous condition is okay. I will get the Jacobian matrix of this function. And be sure that the Jacobian matrix at this point is reversible. You can get the inversion of this Jacobian matrix. And it's just a generalization to the law. dx at f, which is the gradient at f, divided by the gradient vector at y, which is similar to f of x sum f of y. Okay? Very simple. Now functions defined implicitly, this is how it is written in our slides. The information that you had at the time being, it's really enough for you. You can handle these problems successfully, so no worries. I will read it with you, but we already covered this part. شباب اللي موجود دلوقتي ده الاكسبلانيشن بتاع الامبليسيت فانكشن ثيوري بالسلايدز العاديه اللي موجوده معاك الاساسيه يعني. لكن نفس المينينج، نفس المعنى، نفس كل شيء. طبعا اهو implicitly defines y as a function of x in the neighborhood of a point AB اهو point 2. يعني انت عارف فاهم؟ in AB wants such that f of AB equal to 0. So that's the check that the function, okay, is equal to 0. Step number 2, we have two neighborhoods, void V and W regarding the x and y. So we can cross multiplication for them. This is the function phi, which maps v into w, which means phi of x is equal to y. So one of the variables is a function in the other variable. So simply, all of this is stated for here. F is equal to 0. The derivative of f with respect to y is never 0 because you will need it in the division. So simply, if I want to get phi dash, which is dy by dx that we saw previously in the previous example, it's going to equal to the derivative, the partial derivative of the function with respect to x by the partial derivative of the function with respect to y with a negative sign. It's exactly what we saw in the previous example. Okay? Okay, very good. For example, this problem. This will start the problems that you can separate the variables, as you can see. يا شباب ده بيسهل المسائل اللي انا مش قادر اجيب الامبريسيف فانكشن من one side. اهي x سكوير xy y سكوير minus 3. انا عايز اجيب ايه؟ انا عايز اجيب dy by dx for this function. عايز اجيب dy by dx for this function. According للامبريسيف فانكشن theory، اول حاجه انا عايز اجيب الفاليو بتاعت البارشال ديريفاتيف او الديريفاتيف of y with respect to x in the neighborhood or at this point 1 and 1. يبقى انا هتشيك الاول ان الايكويشن equal to 0 function equal to 0 at 1 and 1. then هجيب الديريفاتيف البارشال ديريفاتيف بتاعها with respect to y واتاكد انه مش بزيرو. بعدين ابلاي الثيرد. تعال معايا كده فيرست ستيب. ايه رايك؟ طبعا لازم تبقى f of x و y بتساوي 0. لازم تحطها الفورمولا. يعني لو انا مديها x سكوير بلس x y بلس y سكوير equal بوزيتيف 3، خليها نيجاتيف 3 equal to 0. That's the first step. تعال بقى نجيب f نتشيك ان f at 1 and 1 بتساوي كام؟ ده بيساوي x to the power of 2 plus x times y. الكلام ده خلي بالك plus y to the power of 2 minus 3. Once you substitute by these numbers at 1 and 1, you will discover that Mr. Ahmed, that 3 minus 3, which is equal to 0. So the first condition is satisfied. In the value of the function at 1 and 1 is okay, it's equal to 0. Second step, let's get the second condition. Second condition, get f sub 1, which means differentiate this function with respect to 1. Start differentiating. This is going to be 0. That's going to develop an x. Here we go. Plus a 2 over y, which equal to, at the point 1 and 1. Let's make a substitution. So it's going to be a 1 plus 2, which come up to 3, which doesn't equal to 0. So the second condition is checked. Now I can use the implicit function theory successfully. The implicit function theory states, as we saw in the previous slide, that dy by dx is going to equal to a negative sign for f sub x divided by f sub y. So all I have to do is to get the derivative of this function with subject to x. Do it. So it's going to be a 2 over x plus, or I believe for y squared negative 3 will be both zeros. Of course, divided by partial fy. I'm going to write it as variables, then I will substitute. So it's going to be an x plus a 2 over y. Let's start substitute. Of course, don't forget the negative sign here. Okay, don't forget it. Now start substitutions and 1 and 1. It's going to be negative over 3 by 3, so it's going to come up to negative 1. So the value of the derivative of dy by dx is going to come up to negative 1 at this point. This is how we use the implicit function theory. Okay, once more, verify the conditions. Okay, that's the function. Okay, I'm going to test at 1 and 1, replace every xy by these values. Here we go. That's when we substitute it. It's equal to 0. Then start getting the partial derivative of f with respect to y. Differentiate with respect to y. Okay, check the condition. It's equal to 3, not equal to 0. Now I will start using the implicit function theory, which states that negative dy by dx over partial f partial y, which is simply going to be negative 2x plus y over x plus 2. You need this implicit function derivative specifically at the point 1 and 1. Start substituting, and in a second you will have the value in front of you. Once more, I can do the implicit function here for this guy because I'm separating just only y as a function in x. So if you start substituting, differentiating, that's another solution. It's going to be 2x. Then I will have two functions multiplied in each other. So it's going to be y plus x times y dash. And this guy is going to be 2y dash. Start taking y dash. Here we go. That's the derivative. Start taking y dash as a common. You will end up having exactly the same. So it's working here also. But we mainly, if we were asked about how to get the implicit function theory, these are the main steps. First of all, check the function, get partial f partial y, and make the application partial f. Okay? Partial x divided by partial f partial y with a negative sign. Now, if I have the second version, or I have three variables, and I need to get one of them as a function in the other two variables, and differentiate with respect to this. Is this possible? Yes, of course. It's just a generalization for the main concept that we saw previously. Let's see. I will go through it and I will give you the law by the end of this presentation. So that's U, which is a part of R3. So F mainly maps elements from R3 into R. It takes elements from R3 and map it into R. The equation is f, x, y, and z equal to 0. Implicit defines the variable z as a function of the variables x and y. So I need to express z as a function in x and y. The two neighborhoods of v and w, which stand for the x and y, and this is the terminology of v cross w is a subset of u, and v cross w. So I'm looking for the function z, which is a function in both x and y. Now I can get the derivatives of these functions. These are the conditions. First of all, the function should equal to 0. And the second condition, which is very, very important, that the partial derivative of f with respect to z is not equal to 0. And also makes sense, يا محمد. ليه؟ لأن لو عايز أجيب partial z partial x أقدر. لو عايز اجيب partial z partial x، كل اللي انا هعمله ابلاي القانون ده. partial f partial x بس partial f partial z. الكونديشن اللي جايبه بالنسبه لك ان partial f partial z shouldn't equal to كام؟ to 0. يبقى اقدر اجيب، انا كنت بجيب dy by dx f sub x على f sub y، انا دلوقتي بقدر اجيب partial derivatives of z with respect to the other variables. If you are not following up very well with this law, let's try once more on this problem. خلينا نبص على البروبلم. نبصلها كده. I have, let's consider the surface which is an f of x, y, and z, x squared plus y squared plus z squared, which equal to 9. That's an equation of a sphere. That's equation of a sphere. You already know that from the first part that we spoke about the various types of quadratics and so on. So it's a sphere, okay? With a radius equal to 3. And the center is driven 0. Am I right? Okay, perfect. More than perfect. Now, this is the equation of a sphere of a radius 3, centered at the origin. What we need to do is asking you to determine partial z, partial x, partial z, partial y at the point 2, 1, 2. So mainly, I need to check if I can use the implicit function theory at the point 2, 1, 2. Okay? Which is very, very simple. All I have to do, once more, just make a check that f of x, y, and z will equal to 0 once you use the point which is 2, 1, 2. And this is very, very simple. All I have to do is to make the substitution. So replace x, y, and z by these numbers. So f at 2, 1, and 2 will be 4. plus 1 plus 4 minus 9. Of course, it will equal to 0. So the first condition is okay. The second condition, this is the first condition. The second condition states that get partial f, partial z. Get the partial derivative of f with respect to z, which is very, very simple. It's going to be just only 2z. Start substituting by 2, 1, and 2, which is going to come up to 4, which doesn't equal to 0, so the second condition is okay. Now, I can get the partial derivatives of z with respect to x. And for z with respect to y are partial z partial x equal to negative of the derivative of f with respect to x divided by derivative of an f with respect to z. And if I want to get, okay, partial f, partial of the y, it's really partial z, partial y, I'm sorry. It's really very simple. All you have to do is to get partial f, partial of y divided by partial f divided by partial z. Muhammad, the law is really very simple. All I have to do is to make these direct substitutions. So check IFT conditions. It's already checked. That's the first condition, as you can see. That's the second condition. Okay, the derivative with respect to z is not 0, because once you start substituting, it should equal to 4, which doesn't equal to 0. Also checked. Then I can get simply the derivative of the function. Partial f partial x equal to x, partial f partial y equal to y, partial f partial z equal to z. So the partial z partial x will equal to a negative partial derivative with respect to x by the derivative of f with respect to z. So it's going to be y over z. I'm sorry, x over z. And for the other partial derivative, it's going to be exactly the same. So it's going to be 2y over 2z. So it will end up having negative y over z. Just making direct substitution. Shabab, سهل. Okay, very good. These laws on this problem is very important. خلي بالك يا محمد ان انا هنا بجيب partial f, partial x, partial f, partial y، بس بقدر احصل على الريزلت ان الزد هو فانكشن في مين ومين؟ في x و y، which is really very important. For the time being, I will start with you also about a definition that we went through in the previous problems as an application on sheet on the list of the previous session. But I need to speak with you a little bit more about the directional derivative formula, which is very, very simple. The directional derivative formula states that, first of all, the directional derivative measures the rate of a change of f at a point in a specific direction. Once more, the directional derivative formula that we saw previously, which you get the gradient vector, you bring the other vector, okay, and you multiply them together, okay, and then you will get your directional derivative. So, first of all, that's the law. This is the directional derivative of f in the direction of w. This is row, this thing. So, that's the directional derivative of f with respect to or in the direction of w. All I have to do is to get the gradient vector of f at that point and then multiply it by the directional vector, which is you need to evaluate the direction derivative at. It's really very simple. Of course, the multiplication here, Mr. Ahmed, is a dot product. So it's really very simple. Okay, once more, that point x naught is where you are standing. The location that you want to measure how the function is changing is the w, which is uv. All I have to do is to just get the gradient and multiply. And that's the detailed definition of each one of them. I sent you these definitions, most of them, okay, all of them, actually, on our group. So you will have no problem going through this once more. Ideally, I don't want to waste your time talking about the definition or describing it without solving a problem. By the idea, the previous directional derivative formula will be used in the case of functions when they are differentiable, and this is important because sometimes I will give you functions, as you will see in the list, and it's not differentiable. So you will need, or you are not sure is this differentiable. So you will be in need to use this law. This is the directional derivative, but not with the dot product formula, but with the limit formula, which states limit h tends to 0. Please be careful. It's x naught, which is the point of testing, plus HA and y naught plus HB. What's an A and B? The A and B are simply the coordinates of the vector that you will use. So once more, you have the function in the palm of your hand. Now I will start making the substitution. I will replace every x by x naught plus an h times a. And every y will be also replaced by y naught plus hb. Minus the value of function x naught y naught and divide them on h and take the limit as h tends to 0. So at the time being, please wake up. You have two main formulas for getting the directional derivative in the direction of a vector. The first formula is very, very simple. All I have to get is the gradient vector of f dot the coordinates of the vector that you want to evaluate the directional derivative at, which is very, very simple. But the problem is in using this formula is the gradient vector, because sometimes the gradient vector will be, you will be able to evaluate it, and sometimes you are not going to be able to evaluate it. Once it is, you are in the case of discussing if the function is differentiable or not, you will not be going to be able to get the partial derivatives of this function. Okay, and we will see problems like this probably in the sheet, as you will see just in after some minutes. Once more for the law, I need you to feel comfortable around it. The law states that I'm not going to use this form, okay? I will use this one instead in case of your function is not differential. The law is really, very simple. What I have to do as a steps, take the function that you want to find the directional derivative for. Substitute by x naught and y naught. So this value, leave it. I have it and leave it. The second value, please be careful about this. I will mix two things in this substitution. First, the point, which is x naught, y naught. Then I will add on them some h, which is a variable that I will use in the limit, times a, which is the x component of the directional of the vector that I am evaluating at, and b, also it's going to be this value of the vector that we are computing. This unit vector that we use, it should be a unit vector. It should be a unit vector. And you know how to check if your vector is a unit vector or not. Okay, once more, here is u, which consists of two components, u1 and u2, and this is being a unit vector. Okay, unit vector means if you get the first component square plus the second component square under square root, the result, the magnitude should equal to 1. At the worst case scenario, and it's not equal to 1, all you have to do is to divide the main vector on this magnitude, and it will be a unit vector. Okay, perfect. That's the explanation of the meaning of the directional vector at certain point in the direction of certain vector. As I told you, this is the equation that will depend on evaluating the gradient and the multiply in the vectors. Same way like, let's, you have these slides. Let's see it in action. Let's see it in action. Let's see a problem to feel more comfortable in evaluating the directional vector. Let's see for this problem. Let's see, step by step. Here is f, I'm giving you f, which is 3x plus 2y squared. I need you to evaluate the directional derivative in the neighborhood of the point 2 and 1, or at the point 2 and 1. In the direction of the vector, or the vector, which is a quarter plus a root 3 over 4. The first thing to check is this vector a unit vector or not? So the first step I will do, I will take this vector, which is simply u vector, which is equal to 1 over 4, and then root 3 over 4. To check if it is unit vector or not, get the magnitude of this value, which is going to be 1 over 16, I believe, plus 3 over 16, which is going to come up to a square over 4 over 16. Of course, this value is a number, so it's not a negative value. معايا يا محمد؟ لما اعمل كده ده يديني 2 over 4, which is going to come up to 1 over 2. In this case, I'm sure that this vector is not a unit vector. How to change it to be a unit vector? I will divide each component by 1 over 2. So simply, I will have this vector as a unit vector, a quarter divided by a half, I think we will have 1 over 2. And simply like, it's gonna be a root 3 over 2. Now, if I want to check, the first component to the power of 2 is going to be a quarter. The second component to the power of 2 is going to be 3 quarters. Summing them together, it's going to come up to 1. Under square root, so it's 1. I'm ready for the vector. The second thing, I will need to bring the gradient vector. حد يقدر يجيب لي gradient vector؟ ها؟ Gradient vector of this function. في سؤال يا محمد؟
root 3 على 2 يعني 3 quarters.
ايه؟ قول لي تاني.
ايه حته الكوارترز اللي انت قلتها دي؟
مش انا بتشك ان ده يونت فيكتور؟ انا حولته يونت فيكتور، عايز ابقى متاكد انه يونت فيكتور. يبقى هاخد الفيرست كومبوننت هيديك ربع. هاخد السكند كومبوننت تو ذا باور اوف 2 هيديك 3/4. مجموعهم على بعض 4 over 4 which is gonna come up to 1. under square root هتبقى 1. ماشي؟ يعني انا بعمل تشيك اهو، احنا رايحين بعيد ليه؟ ادي السكوير روت بتاع a quarter plus 3 over 4 which is gonna come up to 4 over 4 which is gonna come up to 1 which is a unit vector. خلاص تشيك متاكدين. ستيب اللي بعدين get the directional derivative. حد يجيب لي كده الدايركشنال I'm sorry get the gradient vector first. That's the gradient vector from F. عشان اجيب الجريدينت vector of F اعمل ايه؟ differentiate 2 times. Okay? First of all with respect to x, then with respect to y. With respect to x, you will end up having 3. With respect to y, simply it's gonna be 4 over 1. Okay? طيب أنا عايز ال values at the point 2 and 1. All I have to do is to make substitutions. So at 2 and 1, I'm sorry, at 2 and 1, so the result